Hello everyone and welcome to another Dash video. In this video we're going to be building off of the dataframe performance benchmark dashboard that I created, where we kind of explore the different dataframe options that are available. We have pandas, polars, and narwhals where we run speed tests on them, but in this video we're going to be diving into polars, where we're going to be building out a Dash application that uses polars, and I'm going to show the different changes that are needed in regards to working with polars and with a different data set. And what we're actually going to be building out is going to be this Excel data viewer, where we're going to be able to click on this button, which allows us to upload a data set. And as you can see here, once we upload the data set, then it's going to create a map where if you hover over the specific points in the data set, then it's going to show those points. And if you scroll down, you can see a dash AG grid, which will be used. So you can also go over here and then you can filter specific things. So if you wanted to remove blank values, as you can see, that value was removed, and it's also removed in the graph itself. So the map will not show any value that isn't in the dash AG grid. So there's a few things that are going on here where you have the upload of the data, you have the rendering of both the data set on the map and the dash AG grid, and then you're also having functionality with dash AG grid to update the map. So to kind of show how all this interconnects and is built out, we can go into the code itself. So some of the things that we're going to need right off the bat is we're going to be working within Dash. So we're going to need to import Dash, DCC, HTML, input, output, state, and callback. These are all going to be used within the application. We're also going to be working with Dash AG Grid to build out the table. We're going to be working with Plotly Graph Objects and Plotly Express to build out the map. Then we're going to be working with polars to build out the data frame, and then we're going to be working with Base64 and IO. So with that, we're going to initialize the Dash application, and then we're going to define our layout. The layout is fairly simple, which consists of an HTML H1 for the title. Then we have this component, which is really powerful, but this is a upload component. DCC upload allows you to drop in files and allow them to be used within your code so that you can change them, you can show them, you can interact with them. So what this needs to work is you're going to need an ID, which will be used in the callback to declare what actions have been taken, what's been uploaded, and how to work with that. Then you have this prop, which is accept, which you can define specific file types for. So if I wanted to extend this further, I could add .css, or I could add .csv, for example, if I wanted different data sets, or if I wanted styling, or any other different file types that I wanted to upload to work with. But for this use case, we're just going to be using the Excel files, which is .xlsx and .xls. So below that upload, we're going to be basically creating two divs. These divs are going to act as the render points for the graph and for the dash AG grid. So whenever an upload happens, then it's going to populate these two containers with the graph and with the dash AG grid that we're looking for. Below that, we're going to also be leveraging the DCC store. DCC store is a way to store data within your application, which helps out a lot in regards to speed. It's easy to work with in the callbacks, and it's just an amazing tool that I will show how it is being used. So first, we're going to create a parse content. This is going to be a helper function, which is going to work in partnership with the DCC upload. What this does is it takes in a contents and a file name, and then it's going to turn that into a decoded way for the Dash application and the Python to read the contents of the file that is being uploaded. So this is using Base64 and Base64 decode to take the actual data of the file and then to decode it. Now this is going to be brought in through a data frame, which is using Polar's read Excel, and then it's going to take in that decoded file, and that's going to render the data frame that is going to be used to build out further within this project. So we are also going to convert the time to a date time object to just check to see if the type of this specific column is able to work as a datetime column. So that's what it's doing. It's stripping the string and it's turning it into a datetime object. Then if we scroll down further, we have callbacks. These callback right here is the upload, which is going to allow us to take in an input. So this is what is being triggered. So whenever you upload data to that DCC upload, then this callback will be triggered, and then it's going to output to the store data, to the output graph, and then to the output grid. So with that, you can see this in action, the function. If no content is provided, then it's not going to do anything. If content is provided, then it's going to create a data frame from this function right here, which you can see this happening. Then it's basically going to convert the data frame to a dictionary to go into the DCC store, which is going to be the data dict. And then you also have the rendering of the graph, which is going to happen within a function, and then the -ag grid, which is going to be created within a function. And this is going to be returned to the outputs right here, which will render within the actual application. So moving down a little bit further, we can see what these actual functions of create graph and create ag grid consist of. So both of these take in a data frame within the function. For the create the graph, it's going to look for the latitude and longitude in the columns of the data frame, and then basically it's going to use polars to strip any values that are not available for the latitude and longitude. So if there's a blank value in latitude or longitude, then it's not going to use it in the rendering of the map, because you're going to need latitude and longitude to plot that within the map. So moving down a little bit further, we have this little if statement, which is used to ensure that the latitude and longitude are numeric, which means that there are a float value, which could be read as, latitude and longitude. Moving down a little bit further, we have this create hover card, which is going to be used on the map itself to show the hover information whenever you hover over a specific point in the map. So then we are going to use a scatter map to basically pass through the data frame that we created. And then we're going to tell it that the latitude is going to be associated with the column latitude, and then the longitude is going to be associated with the column longitude. And then we are passing through the hover data. We are setting a zoom for the map itself to show where the map should render at. And then we are setting a height, and then we have a title for the actual map that we are creating. Then we have this figure update layout, which is just basically defining the color scheme of the map. And then we have this margin to set the margin of the map. Below that, we have this function create ag grid, which takes in a data frame. This is going to be used to render the ag grid, where we are cloning the data frame from the data that was just passed through the function. Then we are going to convert any date time columns to strings for ag grid. Then we are going to create a column definition for each of the columns to allow the columns within the -ag grid to have different functionality, like telling it that you can filter through this, you can sort through this column. Like that's what this is doing. So it's running a loop through the data frame columns, and then it's basically giving the column definitions for what these columns are allowed to do. Moving down a little bit further, we are adding a specific filter for numeric columns. So it's just checking through the columns to make sure that they are numbers where they're supposed to be numbers, they're strings where they're supposed to be strings. This is kind of what this is doing. And then lastly, it's going to add that to the blank list that we have up above. So this is going to populate this list that will be used in rendering the -ag grid. So right here we have this grid variable, which is going to be the -ag grid. We're passing through an ID. We have row data, which is going to be the data frame. We have the column definition, which we defined above. And then we have some default column definitions. We have some grid options. For example, if we want pagination, specific sizes, auto height. Then we are setting style, height, none. The class name is going to be used to tell -ag grid what color you want it to be. So you can use class name to do that. This is just the default ag grid color. And then we are returning this in that specific div above in the layout. So then we also have this callback, which is going to be the update graph from grid, which is used whenever a change happens to dash AG grid, then it will reflect to the map that we created above. And basically the input is going to be the dash AG grid and then the rows within that. And then what we are doing for the output is we are re-rendering the data graph, which is going to be that div where the graph is being rendered for the map. So with this, we're basically just saying like if any change happens to the row data, then I want you to convert it to a data frame using polars. Then I also want you to just make sure that the column time of observation is a date time, and then it creates the graph itself by just checking the latitude and the longitude and filtering out any NA or any missing values within the data. And then it's going to use that filter to make sure that happens. And then it's also going to create that hover data, and it's going to create the figure for the scatter map where we are passing through all the information we just defined. And then it's updating the figure layout, and then it's returning the figure. Else, this is a catch-all where if anything goes wrong, then it will just render a blank graph, basically telling that through the text that something went wrong. So with that, I hope that this was useful in helping you understand how polars works. It's very similar to how pandas work. A lot of the processes are the same. A few of the definitions that you work with might be a little bit different. If you look at pl.col, and then you have different ways of working with it, but the outcome is relatively similar between all the different data sets. So with that, if you like this video, please like and subscribe. Check out the other ones to get a better understanding of how data frames work within each of the different options. And as always, build something amazing, and I'll see you guys in the next one.